Hello everybody, this is Will, and today we're going to look at the Grignard's reaction. The Grignard's reaction, as we know, organic chemistry is really comprised of carbon-to-carbon bonds. Carbon-to-carbon bonds make up most of organic chemistry, and the Grignard's reaction is really a clever way to create some neutrophilic carbon to get some more intricate carbon bonds. Grignard's reaction is named for Victor Grignard, who developed the reaction and eventually won the Nobel Prize in Chemistry in 1912 for the reaction. In this particular example, we're going to look at an alkyl halide with bromine attached to this final carbon. In this compound, this carbon is deemed to be partially negative and this carbon is deemed to be partially positive. By reacting this compound with the diethyl ether solution of magnesium, we can then have the magnesium bond, and this is important, between the carbon here and the bromide here. By doing so, it creates this compound which actually flips the charges of all the participants. This carbon becomes partially positive and this carbon becomes partially negative, which is important for further reactivity. This right here is called the Grignard's reagent. Down here we have the Grignard's reagent, and then we're going to react it with this compound right here. By reacting it with this carbon compound right here, this now newly neutrophilic carbon can attack this center carbon right here, pushing the pi bond up, creating an oxyanion here, as pictured over here. And then this carbon can actually bond to the neutrophilic carbon, giving you a 5-carbon structure such as this. In describing this intermediate, the oxyanion has now become the most important part. This is what we're most concerned with. The magnesium and bromide really is an afterthought. As this is an intermediate, we're not too concerned with this as a final product, but what we can do is we can protonate it. We can add this proton right here, dissolved in water, to get down to this 5-carbon alcohol. So, we stick the hydroxyl group here, 5-carbon alcohol. Now, in this reaction, we've just created an alcohol. This reaction is great for creating alcohols. One synthetic alcohol that can be created with this reaction is formaldehyde. Formaldehyde is a wonderful preservation agent that preserves wood as well as human organs. Formaldehyde is a very valuable compound, and the ability to synthesize it using a reaction such as this is incredibly valuable. Next, if you want to further explore the Grignard's reaction, the ACS right here has a wonderful article authored by Raphael Matthias Peltzer et al. Entitled The Grignard Reaction, Unraveling a Chemical Puzzle. It was published January 17th, 2020, and it looks at all the mechanisms, all the intermediates that can be derived, and it really takes you step by step through the reaction and all the principles that allow it to occur. This has been the Grignard reaction with me, Will. Have a blessed day.